Hi there, my name is Ryan Adams. I am a Senior Premier Field Engineer with Microsoft, and I was a former Data Platform MVP prior to joining the company. Today I wanted to show everyone how Trace Flag 1117 works. Trace Flag 1117 was something that allowed us to help us take care of TempDB contention. What it allows me to do is grow my data files at the same time. And some of the documentation that you're going to see out there will say that it grows them evenly. And unfortunately, that kind of really gives the wrong concept of how this really works. It doesn't grow them evenly. If they're misproportionately sized, we're not going to see it catch one up to the same size as the other. So I'm going to show you how this works. Now in my demo machine here, I'm running SQL Server 2016. Trace flag 1117 and 1118 are on by default in SQL Server 2016. And versions below that, you actually have to turn the trace flag on yourself if you want to take advantage of those. I mentioned 1118 because we also use that a lot with TempDB Contention, and that deals with how we allocate extents, whether they're in mixed extents or uniform extents. And so we'll probably talk about that at another time in the future. So what I want to do here is I am going to start by just setting up our demo. And what we want to do is we want to look at what my TempDB currently looks like right now. So I'm just going to go in and take a look at the files. And indeed, down here at the bottom, I can see I actually do have two files. File ID number 3 is a secondary file that I've created. And we want to start fresh, so we want to get rid of that guy. So what I'm going to do is we're going to run dbcc shrink file with the empty file parameter. What that's going to do is allow me to take any data that's currently in that secondary temp dev2 file and remove it and put it in any of the other remaining files. And of course, the primary file is the only other remaining file. So it's going to take any data that it sees in number 2 and move it over to the primary file number 1. Should only take a second here to do that. And once it's done that and it's moved all of the data out of there, what I'm going to do is I'm going to go ahead and remove the secondary file. That way we're starting clean with a single TempDB data file. And we'll do that very simply with an alter database on TempDB remove tempdev2. So we'll go ahead and do that. We'll get rid of that. And then what we're going to do is we're going to shrink the primary file. Again, this is all for demo purposes, a bunch of stuff you wouldn't want to do in production, but what I'm trying to do here is take the primary data file and make sure he's exactly 50 meg. If he's less than 50 meg, grow him to 50. If he's over 50 right now, we're going to shrink him down to 50. We'll verify, next what we're going to do is we're going to add a secondary data file back, but we're going to create him at 80 meg. So he's 30 meg bigger than our primary. So let's go ahead and do that. And then we'll verify it by inspecting them. And then we can indeed see down here at the bottom, size is 50 meg and 80 meg respectively. So my primary here is 50, secondary is 80. We can also see the growth here. So the growth for both of these said 64 meg, and that's the default in SQL Server 2016. You'll see something different in your environments if you're below that. If you have changed or altered that, and they might not even be the same number necessarily because you can do that independently of each other. So now what we're going to do, now that we've kind of got things set up, and we've got two files, one at 50, one at 80, we wanted to make sure that trace flag 1117 is on, just in case we're using something below 2016. Now for me, since I'm using 2016, it doesn't really matter. What I'm doing is I'm just looking at the major version. If it's major version 13 is SQL Server 2016's version. So if it's less than that, then what we want to do is we want to turn the trace flag on, and we do that with this dbcc trace on, and we turn it on globally, trace flag 1117. Now, interestingly enough, if we wanted to do this in 2016 and we actually wanted to turn it off, we would use this alter database modify file group. This is something that's in the primary file group always. And there's two choices here, and I'm using the auto grow single file. There's also an auto grow multiple files if we wanted to change it to multiple files. But for TempDB, if I were to execute this, I'll actually get an error back that says auto grow single file, you can't set that in TempDB. Now we can set that in our user databases, but for TempDB, that's not something we can turn off. So now what we're going to do is we're going to take advantage of the Wide World Importers, which is the new SQL Server 2016 example database. And all I'm really going to do here is I want to take invoices out of the sales.invoices table. I'm going to create a temp table called invoice. And we're going to take that invoice table and fill it up with everything. Now what I'm really doing is I'm being lazy here in this piece. What I'm going to do is I want to say select top one and then delete the data out of it. I'm really just doing this to do an easy way to create the table. That way I don't have to create the structure itself. So we've done that. We have an invoice table. It's completely empty. What I'm going to do is I'm going to select sales invoices. I'm going to say go to, so it's going to do this twice. It's going to take all the data out of invoices, put it into my temp table twice. It should be around 116 meg is what it's going to put in there. Now remember, we've created a primary at 50, a secondary at 80, so that gives me a total of 130 meg. I just put 116 or so in there. So I have gone over the first data file, but I have not yet filled the second. Because one of the questions I often get is, well, if they're not evenly set, as soon as it fills up the first one, is that when it auto grows? Well, let's find out, because that's what we just did, right? We've put enough data in there that should have filled the first data file and spilled into the second one, but not enough to go over the second one yet. So let's inspect those and see what we got out of that. And here's what we get. My current size is still 50 and 80, so an auto grow has not occurred. In my primary temp file, I can see that I've used 50 meg. Free space is 0, so it has completely filled the primary data file. In the secondary, I've got 80 meg, but what I have used here is 75.875, so I've got about 4 meg free out of this guy. So it didn't auto grow. They're still at 50 and 80 meg respectively, so filling up that very first data file did not cause the auto grow to occur in either one of them. It's not until we've actually filled the complete database that the grow actually happens. So let's go do that and verify that that actually works like we would expect it to. Same deal again. Drop my table, recreate it. This time add data, I'm going to do a go 3. So it's going to do this 3 times. It's going to put about 187 meg in there. What we really want to do is just get over that 130 meg threshold to see what happens. So now let's inspect our file sizes and see what we get this time. And sure enough, if I look at the current size, they did grow. Now 50 meg, and remember I showed you at the beginning we were at 64 meg on the auto grow. 50 plus 64 is, guess what? It's 114. 80 and 50 is 144, so they both grew. But what's important to note here is, even though some of the documentation may use the word even out, it doesn't even anything out. There's no such thing as evening these data files out. It's not going to grow the smaller temp file to the point that it matches the bigger one. That way it keeps them consistent going forward. So if you're going to use a trace flag 1117, you've got to make sure that the data file, every single one of them is exactly the same size. You want to make sure that your auto grow is exactly the same amount and that you're growing by the same file, or the same amount in every data file every single time. That's the only way that you can ensure that you'll consistently grow and all of your data files in TempDB will be perfectly sized exactly the same. So why is that important? I'm going to clean up after myself. I'm just going to go ahead and drop that table. So why is that important? Why do we care about whether these temp files grow at the same size? If I didn't have trace flag 1117 on, as soon as that 50 meg file had hit 50 meg, he would have grown. But because we had the trace flag turned on that says they will all grow at the same time, it waits until it fills up and then it grows the whole thing. Why is that so important? And the reason for that is what we call contention. There are some special files, the GAM, SGAM, and PFS pages, that track the allocation of pages within our database. PFS tracks free page space, the GAM tracks extents that are uniform, and SGAM is mixed extents. And that's how SQL Server internally tracks these. But the thing is there's only so many of those pages in a database. And we won't get into the specifics on that, but Imagine this, if you've got a bunch of people that are fighting over the same thing and only one person can have a turn at a time, then what you've got is you've got a bottleneck. You've created a line where everybody's got to wait to get their hands on that thing first. So how does that work inside SQL Server? And again, if we create multiple files and they're evenly spaced the way they're supposed to be, then what we've done is we've put a gap in there. We've created more of these GAM, SCAM, and PFS special pages, so we were able to reduce the contention on them. But what if they're not even? What happens? So let's start fresh here. We'll verify, yes, I do indeed have two data files. Let's go ahead and empty data file number 2. So we'll get rid of all the data out of there. Let's get rid of him. We'll remove him completely. Now he's gone. We're going to make sure that my primary is at exactly 50 meg, just like we did before. We're going to add a secondary, but this time the secondary file, he's going to be 1 gig in size. So we'll verify that that looks the way that we want it to look. And sure enough, it does. We've got our primary sitting right here at 50 meg. We've got our secondary file sitting here at 1 gig. Of course, our file growth is consistent here at 64 meg for both of those guys. Great. So now what I'm going to do is I've got a stored proc that I'm going to run. He's already created, and what I want to do is create a synthetic workload. What I'm going to do is I'm going to take this line. I'm going to use the ostress utility out of the RML utilities for SQL Server. We'll open that up, and then we'll go ahead and run that. And what he's going to do is he's going to open up 8 threads running that stored procedure, and he's going to run it 300 times per thread. So let's go in here and query and look for contention on those special pages with this query we've got here and see what happens. Now, what I'm really focused on is this resource description right here. And if I run this over and over and over again, the first number is the database number. For me, it's a 2, and that's TempDB. TempDB is always 2. The number in the middle here is a 3. 3 is the data file. So my primary data file is number 1. Data file 2 is actually my log file, and then that 1 gig file I created was 3. And then it shows the page number that I'm having contention on is the last one. Well, guess what? If I keep running this, that 3 in the middle remains. I keep seeing it. Every once in a while, I'm going to see a 1 where I'm going to get contention out of data file 1, but almost all of the time, it's on 3. Which means that instead of having that contention spaced apart and relieving that contention, all I've really done is said, I had a bunch of contention on data file 1. I wanted to relieve it, so I created another data file, but I didn't create it the same size. So all I've really done is take the contention from data file 1, I've moved it over to data file 3 now. I'm still going to experience the same bottleneck. Why? Because I didn't create my files the same size. If I create them the same size, the proportional fill algorithm will use them more evenly, and then we can help relieve contention. So this is why it's really important that we make sure that all of the data files for TempDB are exactly the same size. We want them to grow at the same rate so that they maintain the same size going forward. So I hope you guys have found this beneficial into seeing exactly how 1117 works. Very interesting trace flag, very, very helpful if you find that you have a bunch of contention in TempDB.